Alright, today we're going to be talking about tessellations and symmetry. Our objectives for today, we will be able to identify tessellations, and we will be able to solve problems involving symmetry. So what is symmetry? Symmetry means it is the same on both sides. Line symmetry. A figure has line symmetry if it can be cut into two identical pieces by a line. A figure can have more than one line of symmetry or no lines of symmetry at all. So let's look at this isosceles triangle. We can cut it down the middle for one line of symmetry. It's the same on both sides. Now, for this equilateral triangle, it's the same on all three sides. We could cut it straight down the middle this way, and it's the same on both sides. Or I could go this way, and it's the same on both sides. Or I could go this way, and it's still the same on both sides. Now, a scalene triangle, there's no way that I can cut it that it'll be the same on both sides. So this has one line of symmetry, this one has three lines of symmetry, this one has no lines of symmetry. Another type of symmetry is point symmetry. A figure has point symmetry when the pre-image and the image match after a rotation around a point in the center. So if we can rotate it less than all the way around and have it line back up, then it has point symmetry. I'm going to trace my hexagon here. I'm going to mark that this was the top. Okay? Let's see if I can rotate this and have it line back up. We turn it. Now it's slid a little to the side, but it still lines up after I rotate it. So yes, this has point symmetry because I could keep rotating, and every time I rotated it, this line's going to keep matching up. Now I can do this on the computer. If you wanted to try this out on your paper, I would get a thinner piece of paper and trace it and then rotate it on top of your note sheet. So let's try it with the star. Here's the top. if we rotate the star, and again, my picture's a little bit off, but it does line up if we rotate it. So yes, this has point symmetry. A little tip. Rotate the figure upside down. If it's the exact same, it has point symmetry. So if we took this T shape, I take this T shape and I rotate it upside down, do I have the same thing? No, I have an upside down T. So this does not have point symmetry, but I could cut it in half and have it the same on both sides, so it does have line symmetry. Now let's look at some tessellations. What is a tessellation? Tessellation is a repeating pattern of figures that completely cover a plane with no gaps or overlaps. So this is a regular tessellation because it's made with regular hexagons. It kind of looks like floor tiles. Here's our hexagon. And it's a lot of the same shape, just translated around where they're all touching. So the interior angle measure of a hexagon, remember, how do we find the interior angle measure? N minus 180. N minus 2 times 180 will give us our sum of our angle measures. So 6 minus 2 times 180, 720 degrees, divided by the fact that we have 6 angles, gives us that each interior angle is 120 degrees. So in here is 120. In here is 120, and in here is 120. And if you look, all of those together end up making a circle, which is 360 degrees. So, in order to know what shapes will tessellate, the interior angle measure must be a factor of 360 degrees. Meaning 360 degrees divided by the interior angle will come out to be a whole number. So let's see if the following regular polygons would tessellate. A triangle has 3 sides, so 3 minus 2 times 180 equals 180. 180 divided by our 3 sides. Each one would be 60 degrees. It's 360 divisible by 60 evenly. We get 6. So yes, a triangle would tessellate. What about a square? 4 minus 2 times 180 gives us that there are 360 degrees total in our square. 360 divided by the 4 angles would be that they're 90 each. 360 divided by 90 gives us 4. So yes, it would tessellate. What about a pentagon? That one has 5 sides, which means it has 540 degrees total for its interior angles. 540 divided by 5 angles is 108 degrees each. 360 divided by 108 is 3.3 repeating. So since we didn't get a whole number, this will not tessellate. Pause the video and you try and see if the octagon will tessellate. Did you get the same answer as me? Tessellations are found in a variety of artwork. M.C. Escher is one of the most famous artists that use tessellations. Identify the figure that is tessellated in the following images by M.C. Escher. So in this picture, there's two things being tessellated. We have the white part and the shaded part. What do those look like to you? I think they both look like birds. So this is a tessellation of birds. In our second picture, the white image looks like fish, and the shaded area, it could be another fish, it could be a boat, kind of looks like waves. Could be any of those things. So, some of the angles are given for the fish-shaped polygon in this tessellation. What is the value of x? So the nice thing about tessellations is that all the shapes are the same. So if we look right here, our angle x forms a line with this angle here, kind of the forehead angle of the fish. Well, based on the previous tessellation, that angle is 150 degrees. Since we know that if they make a line, they have to add up to 180 degrees, that means our x angle must be 30 degrees. For your summary, write down 3 places where you see tessellations in your everyday life. See you in class.